Hi everyone, today we're going to look at estimating and comparing fractions. Make sure you understand equivalent fractions before you continue with this video. Click on the little I in the corner to go to the previous video if you haven't already seen it. How do we compare fractions? There's so many ways, so let's go through them today. Firstly, recall from last episode that there is a number line that we can use. So let's say we have between 0 and 1. We can have 1 out of 10, 2 out of 10, 3 out of 10, all the way to half, which is 5 out of 10, etc., etc., to 10 out of 10, which is 1. So we can use the number line to figure out which one is bigger than the other. Let's do an example. Here we have 5 over 8 and 7 over 10. Which way does it go? Does it go is less than? Or does the symbol in between them go the other way, greater than? And we recall that the way we remember this is it's always good to picture it like a Pac-Man. And the Pac-Man always eats the bigger side. So this is small and this is the bigger side. Recall from last lesson that 5 over 8 means we divide out between 0 and 1 into 8 equal parts. So let's go half and then half again. And then we count 5 over 8 would be 1, 2, 3, 4, 5. So 5 over 8 is here. And then for 7 over 10, that means we have to divide into 10, and I've done it previously. And then we count to 7. 1, 2, 3, 4, 5, 6, 7. So 7 over 10 is here. So we know that 7 over 10 is bigger than 5 over 8. So we write the symbol this way. 5 over 8 is less than 7 over 10. So let's have a look at this question, 2/3 and 5/8. Let's do 2/3 on top of the number line. So we'll try our best to divide this into 3 because the denominator is 3. And we go to the second little bump. That's where 2/3 is. Now let's do 5 over 8. I'm going to do that underneath here so you can see how I'm dividing the number line. So divide that into 8 bits. So chop in half, then in half again is 4, and in half again is 8. Now 5 over 8 is 1, 2, 3, 4, 5. So 5 over 8 is a little bit less than 2/3 because it's closer to 0. So therefore 2/3 is bigger. So we have the bigger side and the smaller side. So if you ever forget how to draw the symbol, put 2 dots on the bigger side and 1 dot on the smaller side. Small, big. And if it's the other way around, 2 dots on the big side, 1 dot on the small side. How else can we compare fractions? We could use the fraction wall. So the fraction wall has 1 as a whole, and we can find these and compare them. So 7 over 10 would be 7 of these. So 3, 6, 7. So we are here. Color that in. 7 over 10. And then 3/8 would be here. And then 5, 6 would be this one here. 1, 2, 3, 4, 5 goes up to here. And 3/5 would be here. So now when we compare the fraction wall, we can see that 5, 6 all the way here is the largest. So we have 5, 6 as our largest. And then the next largest is this one, 7 over 10. And then we're looking at the next line here. 3 over 5 is the next largest. And the tiniest one is 3 over 8. Be very careful with the question. This is in descending order, meaning that it's getting smaller. And if we wanted in ascending order, meaning going bigger, then we would write it the other way around. So the smallest one would be, trying to write it over there, 3 over 8. Then we have 3 over 5. Then we have 7 over 10. And then 5 over 6. So we can use the fraction rule as another way to compare fractions. What else? Sometimes it's easy to compare fractions. It feels like we just know the answer. For example, a half and a third. Well, we know a half and we know what a third looks like. And we know a half is definitely bigger than a third. A half or 2/3. Well, if that's a half, we know 2/3 looks like that. So we know that a half is less than 2/3. Now, when it comes to this question, we can compare it to, well, we know that 7 over 8 is more than a half. But we know that 2/5, well, a half of, if out of 5, if I had 5 slices, half of it would be 2.5 slices. So 2 slices would be less than a half. So we know that 7 over 8 is going to be bigger than 2 over 5. And 5/10 is exactly half. And 8 over 9 is definitely more than half. So if we have exactly a more, we know that 5 over 10 is definitely less than 8 over 9. So that's one way to check when we compare them to a common number. In this case, we compared it to half. Let's have a look at the following question. 1 over 8 or 2 over 8? Well, we recall from previous lesson that these are like pizza slices, these fractions, because they're made out of 8. And the larger the numerator or the more pieces you have, the bigger it is. So in this question, it's clear to say that 2 over 8 is definitely bigger than 1 over 8, or 1 over 8 is smaller than 2 over 8. What about when we get 24 or 18 over 30? Then the one with the bigger numerator will be bigger. So in this case, we have 24 over 30 is bigger than 18 over 30. So we're looking at the numerator when the denominator is the same. So for this one, yeah, 8 over 12 is definitely smaller than 9 over 12. And we can use the diagrams to check our answers. We can see that one is bigger than the other. What are these questions? Sometimes it's quite tricky to tell because in this scenario, both are a little bit more than half and these are a bit less than half. They're both a little bit less than half. These are both somewhat more than half and they're both almost zero. They're very small fractions. And these are both a bit more than half. So how do we compare these? Remember the equivalent fractions, how we wrote the same fraction in different ways? That's what we're going to use today. Let's test our theory with something nice and simple because we know 2/3 and 3/4. 2/3 looks like this and 3/4 looks like this. And we know 3/4 is going to be bigger than 2/3. Let's see if we can use the equivalent fractions to show that it's true. So we're going to find multiples of 3 and multiples of 4 so that we can get a common denominator. And then we just have to look at how many pieces or what the numerator is to compare which fraction is bigger. So the multiples of 3s and 4s are the following. And we can see that there's a common one over there, which is 12. So we're going to write 2 over 3 in terms of 12s, and we're going to write 3 over 4 in terms of 12, and then we're going to compare them. Now to go from 3 to 12, we multiply by 4, and remembering from equivalent fractions, whatever you do to the bottom, you do to the top. 2 times 4 is 8. And from 3 to 12, we multiply by 3 to get there. So whatever you do to the bottom, you do to the top. So 3 times 3 is 9. So we can see that 9 is more than 8, and we were right. 3/4 is greater than 2/3. And the method of using a common denominator also works, which comes in really handy for the following questions. So let's have a look at these tricky questions. 8 over 15 or 8 over 10. So we look for the multiples of 15 and the multiples of 10. and we write them all out until we find something in common, which is 30. So now we can write them both over 30. So 15 times what is 30? We multiply 15 by 2 to get 30. So now we have to multiply 9 by 2 to get 18. And we do the same with the other fraction. What do we multiply the 10 to get 30? We multiplied it by 3. So now we must multiply the top number by 3. So 8 times 3 is 24. Now we can see that 18 is clearly less than 24. So we know that 9 over 15 is less than 8 over 10. Let's do the next question. Which of the following is bigger, 4 over 16 or 6 over 20? Again, we have to find the common denominator by looking for the lowest common multiple. We notice that 80 is going to be our common multiple. Oops, that didn't highlight. We notice that 80 is going to be our common multiple. So now we have to think about numbers that multiply to get to 80. So 16 times what is 80? 16 times 5 is 80. So we multiply 4 by 5 as well to get to 20. 20 times what is 80? Well, 20 times 4 is 80. So we multiply 6 by 4 to get 24. Now that they have a common denominator, we realize that 24 is bigger than 20. Therefore, 6 over 20 is bigger than 4 over 16. So this side is bigger. So how do we compare fractions? There are various methods we use today, so let's recap. We use the number line. We'll put them on the number line and see which one was furthest to the right. That would be the biggest one. Then we visually saw which one was bigger by drawing them or using a fraction wall. We also compared them using a common number, for example, half. We know some fractions are a bit more than half, some fractions are less than half, and therefore we know which one's bigger or smaller. And just now we found the lowest common denominator and we compared the numerators to see which one was biggest. If they're mixed numbers, you can always convert them into proper fractions first, and then make sure they have a common denominator by using equivalent fractions to compare them. To do that, refer to the video that we covered previously. Okay, bye!